Pascal's triangle is made up by putting ones down one side, ones down the other side, and when you get to the first row here, you add these two numbers 1 plus 1 to give you your 2. And here we add 1 plus 2 to give us our 3, 2 plus 1 here to give us our 3, and then down here we have 3 plus 1 to give us our 4, 3 plus 3 to give us our 6, and 3 plus 1 to give us our 4, and so forth. And that's how you make a Pascal's triangle. Now we can use Pascal's triangle to expand x plus y to the n. And right now it's showing to the 4, which is this guy down here, and it's saying that this is how we would solve it with this line here. But before we get there, let's take a look at what x plus y to the 0 would mean. X plus y to the 0 would be 1. X plus y to the 1 would be x, 1x plus 1y. 1x plus 1y. In this case, x plus y squared would be x squared plus 2xy plus y squared. X plus y cubed would be x cubed plus 3x squared y plus 3xy squared plus 1y cubed. So here I think you'll see that this is going to be 1x to the 4th here plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. And we can use Pascal's triangle to find out x plus y to the nth, starting at 0, 1, 2, 3, 4, 5, and so on. What we're going to look at now is simplification of fractions. We all know what a fraction is. It's made up of a numerator over a denominator. And you can also think of the fraction such as x over y here as a ratio if you like. Division by 0 is not permitted, so let's take a look at this particular expression here. And when you factor it, you end up with this. And you can see that you can't have 0 on the bottom, which means you cannot have x is equal to 2 or x is equal to 3. Let's take a look at what it looks like as a graph. If we plot the graph of 3x over x minus 2 times x plus 3, we're going to get 3 lines, one here, and one here. So this is the graph of 3x over x minus 2 times x plus 3, which never touches x equals 2 and never touches x equals minus 3. Common fractions are fractions whose numerator and denominator are both integers, such as 2 over 3, minus 9 over 5, minus 124 over 125, and 18 over minus 11. An algebraic fraction is one whose numerator and or denominator contain an algebraic expression. So these are all examples of an algebraic fraction. An algebraic fraction is called rational if the numerator and the denominator are both polynomials. So these are 3 valid algebraic fractions. However, this is not a polynomial because it has a square root. And since there's no perfect square root for the numerator, this is not a rational algebraic fraction. A proper fraction is one whose numerator is smaller than the denominator. So 3/5, 1/3, 9/11 are all proper fractions. However, 8/5, 3/2, and 7/4 are improper fractions because the numerator is not smaller than the denominator. A proper algebraic fraction is a rational fraction whose numerator is lower than the denominator. Since this is x to the 1st power here over x squared, this is a proper algebraic fraction. Since x squared here is the largest exponent here and x cubed is the largest one here, numerator's value is less than the denominator, so again it is also a proper fraction. Since the degree of the numerator is bigger than the degree of the denominator, this is not a proper fraction. Same here, x squared is bigger as a degree than y, so again it's not a proper fraction. These are referred to as improper fractions. Fractions can also be of mixed form, where a mixed number is a sum of an integer and a fraction, such as 2 plus 1/2, 5 plus 3/4, and 3 and 1/3. A mixed expression is a sum or difference of a polynomial and a rational algebraic fraction. For example, 3x minus 2 plus 1 over x, y minus y over y squared plus 1 are all examples of mixed expressions. To change a fraction to an equivalent decimal, you simply divide the numerator by the denominator. In the case of 9 over 11 here, you're going to get 0.81818181, which is most commonly written as 0.81, where the 0.81 has a bar over it, indicating this is the repeating part of the decimal. If you try and express a decimal as a fraction, in this case 0.875, it's really 0.875 over 1. Now if you multiply top and bottom by 1,000, you get 875 over 1,000, which can then be written as 7 over 8. If you want to change a repeating decimal, such as 0.81 repeated to a fraction, then you can say let x equal this number, and then depends on how many digits are repeating. In this case, we have 2 digits that are repeating, so that's going to be 10 to the 2, or 100x is equal to this. Now, if you subtract x from 100, you're going to get 99x. When you subtract these, the repeating part goes out, and you're left with 99x equals 81, which then gives you x is equal to 81 over 99, and when you divide out by 9, you get this final result that x is equal to 9/11. Now, a lot of times you can simplify a fraction by reducing it to its lowest term. So if you have a common value such as d, you can divide out the d's here to get a over b. In the case of this, you can write 9 here as 3 times 3, 12 is 4 times 3. You can divide out the 3's and get 3 over 4. Same thing here, we can divide the 3 here and get 3 on the bottom. X squared by x, y here on the top, and z here will give you z squared on the bottom. And if you want to write these as it says without negative exponents, you can then rewrite it as x over 3y z squared. In example 13, it shows us how we can actually factor down to get our final value here to the lowest possible expression. Part D here is fairly difficult until you see that this is x times x minus a plus 2b times x minus a, and finally you can factor it out and cancel out the like factors of x minus a to finally get x plus 2b over 2x plus 3a. Sometimes you can simplify a fraction simply by changing the sign. And in our case we've got minus 1 in front of this, which you could then multiply minus 1 times the top to give you 2 minus 3x over 2 minus 3x, which gives you 1 down here. Or you can multiply the bottom by minus 1 and get 3x minus 2 over 3x minus 2, which again evaluates to 1. What value of x is not permitted in this expression? 7 over x squared minus 3x plus 2. This would mean that the denominator would somehow have to be equal to 0, because that is not allowed. That gives you an invalid result. Now, that means that this would have to equal 0. And if we want to use the minus b plus or minus the root of b squared minus 4ac over 2a, we get that x is equal to 2, or x is equal to 1. And if we substitute this back in to here, we'll see that x minus 2 times x minus 1 indeed gives us this back when it's factored. Therefore, x cannot be equal to 1 or 2, or you will be dividing by 0, and this will not be a valid result.